Hey everyone, welcome back with a new lecture with Quality Control Quality Assurance Training course. In the previous lecture, I have explained how to prepare calibration standards, whether from liquid or powder standard, and also how to select the calibration levels. In this lecture, I will explain the matrix effect and what can you do if there is effect from the matrix on your target analytes. But before that, you should know that to verify that your calibration is accepted or not, is accurate or not, you should run verification standard with every sequence. This verification standard can be from the same standard that you used for calibration or from another brand or another company, but in both cases that will be accepted. And you should select this verification standard to be in between your calibration levels. You can select the middle concentration as example. So, because as I said before, that every result that you will get from the instrument should be in between the calibration curve calibration levels to be quantified accurately. As example, if your calibration from starting from 1 up to 100 microgram per liter, so you can select as example 25 microgram per liter to be your verification standard. And to be accepted, to say that this verification standard is accepted, recovery should be plus minus 10%. So recovery should be from 90 up to 110%. If recovery was lower than or higher than this recovery, so this calibration should be rerun again, or you can prepare again the calibration standards and run again. In some cases, you don't need to run. As example, in case of HPLC, mostly they don't run calibration with every sequence. They need only to run verification standard for, as example, 3 months. Then they will again prepare the calibration standard after 3 months and run. So you don't need, in some cases, to run calibration with every sequence, but you have to run verification standard with every sequence to ensure that this calibration is still valid. But if you find that the verification standard not accepted, the recovery of the verification standard not accepted, not within this range, you should prepare again the calibration standard and run, even if the 3 months that you determine not finished. You should prepare again the calibration and run again. But if verification standard recovery was accepted in this 3 months, so you don't need again to rerun the calibration. But in some cases, in some other cases, they need to run the calibration with every sequence. As example, in case of degradable or volatile compounds, they need to run calibration daily with every sequence to be sure from their quantitation. In these cases also, you need to run verification standard to ensure that this calibration was accepted. And also R square value should be higher than or equal to 0.995. In some other guidelines, higher than or equal to 0.99. According to the number of compounds. If you have multi-compounds, as in case of pesticides, you can go for 0.99, but in most cases, it should be higher than or equal to 0.995, that for calibration curve, the slope of calibration curve to be accepted. And now, matrix effect. Matrix effect or effect of matrix interferences on target analyte. Some matrices have a lot of interferences which can affect on your target analyte by enhancement or suppression. By enhancement, it can increase the concentration of target analyte. So it can affect by enhancement or suppression. These interferences or these compounds inside the sample, or see this matrix itself, if it contains fats or colors or whatever, it can increase the concentration of your target analyte or decrease the concentration of your target analyte. And what you can do in these cases, because you should remove this effect of matrix, because that will be consistent. Always you will find this, and that's systematic effect. Systematic effect always happen, every time will happen. So you need to remove this effect from your target analytes to get the real concentration of the target analyzer. And to remove this effect of matrix, you have three solutions. First solution, to prepare matrix matched calibration curve, to prepare the calibration curve but on the matrix itself, And second case, which use the internal standard. You can use internal standard. Everyone will be explained in details. And the last one and the easiest way to prepare standard matrix sample, and also that will be explained. The first solution that I will explain in this lecture only, inshallah, to prepare the calibration curve on the matrix itself. And this is the most difficult, and everyone escape from this solution, to prepare the calibration curve on the matrix, because you should prepare this calibration on every matrix you have. As example, if you analyze 3 or 4 matrices, you should prepare this calibration on every type of matrix, or the best solution to select representative matrix for each group. As example, if you analyze vegetables, fruits, tissue samples, you will select a representative matrix for each one of them, and you will prepare calibration, one calibration curve for vegetables, and the other calibration curve for fruits, and the other calibration curve for tissue samples, or whatever, for leafy vegetables, or for whatever. So you should run on every matrix you have, or representative matrices, and in both cases it's very difficult, because in the normal case you will run the calibration curve or prepare the calibration standards on the solvent for all matrices. So that's the best solution. And also, to prepare the calibration standard on the matrix itself, you will run that from the beginning till the end, same like the routine samples, and that's very difficult, and it cannot be highly accurate as you will prepare in the solvent. How to do this? To prepare, as example, you have your standards should be 1, 5, 10, 25, 50, and 100 microgram per liter, and you will prepare these concentrations on the matrix. You select the matrix and you want to prepare them. First, you will prepare from the beginning. You will add the standard from the beginning. You want to prepare, as example, from 1 milligram per liter, from 1 ppm. So you will take the weight of your sample. As example, the weight of your sample 2 gram. 2 gram sample you will add. Then you will add your standard. So first 100 microgram per liter, 100 microgram per liter, or per kilogram now, 100 ppb, multiplied to 2 gram sample. You want to you want to add, fortify this sample with 100 microgram per liter, or per kilogram on 2 gram sample from 1 milligram per liter, multiplied to which volume you should add. So 200 microliter. You should add 200 microliter on this sample to get 100 microgram per liter. That in case if dilution factor in your method equal to 1. But if the dilution factor for your method, as example, 2, so this 100 should be 200. Because on the instrument will be diluted 2 times and it will be 100, or you can add this 2 on the instrument, but better to prepare that from the beginning. So you will prepare 200 microgram per liter per kilogram multiplied to 2 gram sample from 1 milligram per liter equal to which volume you want to add. And this 200 microgram, 200 bbb will be on the instrument 100 bbb, 100 bbb. That in case of the first or higher level. Then you will prepare again also 50 bbb by the same case, 50 bbb multiplied to 2 gram from 1 milligram per liter, 25 bbb, and so on. Then you will prepare 10 from 100, 5 from 50, 1 from 10. That will be easy. And these 3 concentrations will be prepared from these concentrations, serial dilution. But first, you should do this at the beginning. You have 3 samples will be run to prepare the calibration at the beginning. At the end, after you will finish, you can dilute these concentrations to prepare 10, 5, and 1 bbb. That you will do with every representative matrix, as I said. And another way also to prepare matrix matched calibration, which is better and easier also than the previous one, to prepare at the beginning only blank sample. Now blank sample, 2 grams from the sample, and you will run this blank sample same like the routine samples from the beginning till the end during the whole procedure. And finally you will get the solution inside the tube. And I found this is better than the previous way, because now you will not add the standard at the beginning. There will be no other effect, only the effect of matrix at the end, the matrix effect at the end. But during the whole procedure, there will be no other effect on the standard that you fortified. But finally, you will get the solution. This solution, you will prepare the calibration on this solution. So there is no other effect during the whole procedure on the standard that you fortified, but only the matrix effect at the end. You will prepare 100 microgram, 100 BBB multiplied to 1 ml. You want to prepare 100 BBB in 1 ml HPLC vial from 1 ppm. So you will add 100 microliter. 100 microliter from the standard, from this standard. 100 microliter from this standard plus 900 microliter from the sample solution. This sample solution, you will use 900 microliter from this. And also same for 50 BBB, you will add 50 microliter from the standard plus 950 microliter from the sample solution. And 25 BBB, same like this, 25 microliter plus 975. And 10 you can prepare from 100, 5 you can prepare from 50, 1 you can prepare from 10, that will be serial dilution. So now I found this the right way to prepare the matrix matched calibration, not to add the standard from the beginning. So you can add the standard from the beginning, and you can keep and add the standard at the end, and you will prepare only one sample, one blank sample from that representative matrix that you select. Finally, you will add on the sample solution your calibration curve. That will be on the matrix itself. You will remove the effect of matrix, but there will be no other effect from during the whole procedure. That because during the whole procedure there are many other effects, not only the matrix effect, and that will be calculated during the recovery or from the spike sample.